The next layer we want to look at is layer 4, or the transport layer. The transport layer does several different things. One, it ensures that messages are delivered error-free to their destination. It also ensures that messages are delivered in the proper sequence that they were transmitted in. The transport layer also ensures that the messages it delivers are without loss and are not duplicated. Part of the job of the transport layer is to relieve protocols found in higher layers of the OSI model from concern for transferring of the data. The transferring of the data all begins at the transport layer and therefore is not a concern for the layers above it. The size and complexity of the transport protocol being used on a network is directly dependent on the services provided by the protocol located on the network layer. The more functionality that the network layer protocol provides, the less functionality that the transport layer protocol has to provide. One of the functions of the transport layer is something called message segmentation. What this means is the transport layer accepts messages from the session layer above it in their entirety. Once the transport layer has the message from the session layer, it then splits that message up into smaller units that can be sent across the network. Part of the segmentation process of the transport layer is to impose message size limits on the network layer protocols below. That way, the network layer protocols below don't try to send messages that are larger or smaller than the transport layer is trying to pass on to it. Once the transport layer breaks up the messages into smaller units, it then creates a header for each one of the smaller units it has created. These smaller units are then passed down to the network layer for transmission across the network. Once the message reaches its destination, the transport layer is then responsible for reassembling the message into its entirety before passing it up to the session layer on the destination computer. The header the transport layer creates for the segments it generated contains certain elements. One, they contain start and end flags. This is basically flags that indicate when the segment starts and when the segment ends so that segments won't get confused or pushed together. The header also contains sequence information so that even if the segment arrives at the destination in the wrong sequence, the sequence information can then be used by the transport layer on the destination computer to resequence the message in the order it was intended to be viewed in. Beyond this, there are a few other functions that the transport layer has. One of its functions is message acknowledgement. Basically, message acknowledgement is responsible for providing reliable end-to-end delivery of messages. Not only does it provide the end-to-end delivery of the messages, it also makes sure that acknowledgement is accompanied by that message so that both the source and destination can know that the message was safely sent or received. Message traffic control is another function of the transport layer. Basically, the transport layer controls the rate of traffic sent when there are no buffers available. In other words, if there are no buffers available in the device that's sending out the segments, then the transport layer will take over control of that to make sure that the data rate stays at a certain rate that is manageable by all the devices that are in the network. The transport layer also handles session multiplexing. Basically, session multiplexing is the ability of the transport layer to break all the data coming into a certain link into separate data streams based on the higher level protocols that the data is intended for. Each one of these data streams that are generated based on the higher level protocols is called a session. Part of the transport layer's job is to keep track of which message belongs to which session. One thing to keep in mind about the transport layer is that the transport layer and those above it are not responsible for the transmission between nodes. That is the job of the network layer and the data link layer in particular. However, the transport layer and those above it are responsible for source to destination transmission. This is what is called end-to-end transmission. Upper layer protocols do not need to concern themselves with the underlying communications facility of the network. That is the responsibility of the network layer and the data link layer below it. The next layer we want to look at is layer 5, or the session layer of the OSI model. The session layer is responsible for establishing sessions between processes running on different computers. Now, the important thing to take away from this is that the session layer establishes sessions between processes running on different computers. It does not establish the connection between the computers. It establishes the connection between processes that are already running on the computers. To accomplish this, there are several different functions the session layer has to be responsible for. One, the session layer has to be able to establish, maintain, and terminate the connections. Also, while the connections are running or while the connections are up, the session layer also needs to be able to support those sessions or those connections. To establish, maintain, and terminate a connection, the session layer has to allow the application processes on the different machines to do several different things. One, it has to allow the processes to establish the connection in the first place. Next, it has to allow the different processes to actually use the connection. Finally, the session layer also has to allow the processes on the different machines to terminate a connection once they're done with it. These connections are what we call sessions, and is also where we get the term session layer. In the course of supporting a session, there are a couple of functions that the session layer needs to perform for the network. One, during the process of supporting a session, the session layer provides security for the connection. Also, the session layer provides name recognition so that it can keep the different sessions that are running simultaneously on a computer separate from each other. The session layer also has to be able to log on and, in the end, log off of a session once it's done. These are the primary functions that the session layer carries out while it's supporting a connection or a session. While there are a few other functions that a session layer may do, they are so minor that we won't get into them right now. The next layer of the OSI model we want to talk about is layer 6, or the presentation layer. The presentation layer is responsible for how the data is formatted to be presented to the application layer above it. Part of this formatting process is being able to act as a translator for the network. The way this works is the presentation layer on the sending station, for example, will take the data from the application layer and format it into a common format that is recognized by the network and can be sent across the network. Conversely, on the receiving station, the translation layer will take the common format that is sent across the network and translate it into a format that is used by the application layer above. Part of the translation process, or part of the translation responsibilities of the presentation layer, is to do character code translations. For example, it might take data that is in the form of the ASCII code and convert it or translate it to the EBCDIC code. ASCII is a very basic encoding method used to take plain text and encode it in such a way that it can be sent across the network. EBCDIC, on the other hand, is a much more advanced encoding method that is used in emails and things like that, which allows email to be used to send graphics and pictures and that sort of thing. Data conversion is another responsibility of the presentation layer. Data conversion can be something as simple as changing bit order or altering bit order, or it can be more elaborate, such as controlling carriage returns and line formatting. Also, data conversion can involve going from integer numbers to floating point numbers, or the other way around in case of mathematical functions or algorithms that need to be carried out. Beyond the translation, the presentation layer has a couple of other functions it is responsible for as well. One of these functions is data compression. Data compression is basically taking data and reducing the number of bits needed to transmit the data so that we can transmit more data in the same amount of time across the network. Along with compression, the presentation layer is also responsible for data encryption. Encryption is the process of taking data and running it through an algorithm to create a code that can't be easily read as the data moves across the network. This is done for security purposes and also for privacy purposes, among other things. Encrypting passwords is another form of encryption that the presentation layer is involved in. In the case of passwords, what happens is the presentation layer takes the password or the passphrase and converts it into an encrypted format that is not easy to read before it sends it across the network. Otherwise, if it did not encrypt the passwords would be sent across the network in what's called the clear, meaning the passwords would be clear and plain for everybody to read. This is, of course, not very useful when you're trying to secure your communications or trying to secure the authentication on your network. You want to be able to keep your passwords hidden from somebody that might be eavesdropping. Layer 7, or the top layer of the OSI model, is the application layer. The application layer basically serves as a window for both users and applications running on a local machine to be able to access the network services available to it. To do this, the application layer provides a wide variety of commonly used functions. Some of the functions that are provided by the application layer are these: resource sharing, device redirection, remote file access, remote printer access, network management, directory services, email, instant messaging, and a wide variety of other functions. We'll look at some of the additional functions provided by the application layer when we look at the TCP/IP model.